Hi everybody, Mrs. Sayed here. I hope you guys are all doing well and coping with this quarantine life positively. Today's lesson is about empirical and molecular formulas as well as percent composition. Just a heads up, this is our last kind of lesson before the next quiz that we're having. So if you do have any questions, please reach out to me. The next class will be a quiz, and it's the last class before spring break. So I felt like I want to give you guys a quiz before we have break and forget everything. So today's objectives are to explain what is meant by the percent composition of a compound and also to determine the empirical and molecular formulas for a compound for mass percent actual data. So I'm going to go over about 3 slides and then I'll do a few example problems for you guys. So first, percent composition, it's pretty simple. I would definitely write down the formula written in black over here. So percent composition, or another way to say is percent by mass, is just the mass of an element over the mass of the entire compound times 100. So I'll do an example problem, you'll see what I mean. It's pretty straightforward. Then we have empirical formulas. So empirical formula is basically if you have a compound and you look at the subscripts and they're able to get simplified, the simplified version of that compound or formula is the empirical formula. So for example, if you look at the bottom, the molecular formula for hydrogen peroxide is H2O2. And if you take a close look at the subscripts, they're all divisible by the same number. So when you see that's possible, then the empirical formula exists. So you just simplify it. So for this example, H2O2, all the subscripts are divisible by 2, so it gets simplified to HO. So sometimes the empirical formula will be the same as the molecular formula. That's only if the formula cannot be simplified. If it can't be simplified, then they'll be the same. If it can be simplified, then they'll be different. Lastly, molecular formula specifies the actual number of atoms of each element in one molecule or formula unit of the substance. So if you need to know exactly how many atoms are in the compound, you look at the molecular formula. It's always a whole number multiple of the empirical formula, right? So that's the 3 slides, and now I'm just going to do a few example problems for you guys. All right, guys, so this is an example problem for percent composition. What is the percent composition of carbon in C2H6? So you should have written the formula down, and the formula is just the percent composition equals the mass of the element over mass of compound times 100. So according to my problem, what I'm going to fill in here, the mass of my element is going to be the total mass of carbon. And then the mass of the compound will be the mass of C2H6. Right? So first let's just calculate the whole mass of the compound, which was what last class's lesson was about. So I'm going to figure out the mass of C2H6. Okay, so using my periodic table, I'm going to have to look up the atomic weight for each element. So for carbon, the atomic weight is 12, but I have 2 carbon atoms, so I need to multiply that by 2. And for hydrogen, we can just say that the atomic weight is 1, and there are 6 hydrogens. So I need to multiply that by 6. So 12 times 2 is 24. 1 times 6 is 6. Then I just have to add these 2 numbers up to get the total mass. So 24 plus 6 equals 30 grams per mole for C2H6. Okay? And so I know that's what's going to go in my denominator. So let me just do percent equals 30 grams per mole. And then the mass of the element, so the mass of carbon is going to actually be 24 because there are 2 carbons in my compound. So don't just write what it says on the periodic table. You have to make sure to see how many of that element you have. So yes, the periodic table says that the mass of carbon is 12, but my compound has 2 carbons, so I need to account for that. So I have to write 24 grams per mole times 100. So 24 divided by 30, you can plug that into your calculator, times 100 will give you 80% carbon, okay? So that's the percent composition of carbon. All right, so this is another example problem where it's asking us to determine the molecular formula. So the problem says determine the molecular formula of a compound with the empirical formula CF2 and molar mass of 200.04. So I know my empirical formula is CF2, which means that's just a simplified version of what the molecular formula is. So I kind of have to figure out how to make this unsimplified using the molar mass that's given. So basically for these problems, all you have to do is divide the molar mass of the molecular formula by the molar mass of the empirical formula. Sorry, I can't spell. Okay. And whatever number you get, you multiply all the subscripts in the compound by that number. So you'll get what I mean in a sec. So I know that the molar mass of my molecular formula is 200.04. Okay, that's the molecular. I need to figure out what the empirical molar mass is, and I could do that because we already know how to do that, right? We're just going to figure out what the mass of CF2 is. So CF2. Now, when we're calculating the mass when it comes to empirical and molecular formulas, do not round anything. It's actually very important to just use decimals exactly how you see it on the periodic table. So for the mass of carbon, I'm not going to round it to 12. I'm going to use 12.01. Okay, and I just need to multiply that by 1 because I know I have 1 carbon. The mass of fluorine is 19.00 exactly, and I'm going to multiply that by 2 because there are 2. Okay, so once you do the math and you then add these together, your total should be 50.01, okay, grams per mole for CF2. Now all I have to do is plug in my 2 values. So I'm just going to do the molar mass of the molecular formula. I'll just write it right next to it, which is 200.04. And then the molar mass of the empirical formula, which is 50.01. If you plug that into your calculator, you'll get exactly 4, okay? And these problems, you're always going to get a whole number. If you didn't get a whole number, then you didn't do something right, okay? Now the last step, I'm just going to multiply the subscripts by that number. So I started with CF2. I'm going to just multiply that by 4, okay? So carbon, if there isn't a subscript, we know that's 1. So 1 times 4 is 4. And then for fluorine, I'm just going to do 4 times 2. So for fluorine, it's going to be 8. Okay, and then that's it. That's the molecular formula for this problem. Okay, so basically you just have to divide the molar mass of the molecular formula by the molar mass of the empirical formula. You'll get a whole number, and then you multiply that empirical formula by the whole number and you'll get your molecular formula. All right, guys, so here's another example problem. It's a little more complicated, so bear with me, okay? We'll be able to get through it though. A compound is found to be 40% carbon, 6.7% hydrogen, and 53.5% oxygen. Its molecular mass is 60 grams per mole. What is its molecular formula? So this is kind of a two-step problem because we'll be using the percent compositions to figure out the empirical formula, and then we will use the empirical formula to figure out the molecular formula, which is what the question is asking us. So step one is to divide the percent composition of each element by its molar mass. So for example, for carbon, the percent composition is 40. I'm going to divide it by its molar mass, which is 12.01. Then I'm going to do it for hydrogen. So the percent composition for hydrogen is 6.7, and I'm going to divide it by its molar mass, which is 1.008. And then I'm going to do it for oxygen. The percent composition is 53.5. Then I'm going to divide it by its molar mass, which is 15.999. Okay, so use your periodic table to find out what the molar mass is, okay? And whatever your periodic table says, use that mass exactly. So if you do the math for each one, okay, for carbon, you'll get 3.33. For hydrogen, you'll get 6.647. And for oxygen, you'll get 3.344. Right? So this was step one. Okay? Step two is now that you have these values, you're going to figure out which one is the lowest, and you're going to divide all of them by the lowest value. So these two are basically almost the same number, but I'll say this is the lowest, and I'm going to now divide each number by that value. So 3.333 divided by itself is 1. 6.647 divided by 3.33, if you put it in your calculator, just round it to the next whole number. So it's going to be 2. It's very close to 2. And then 3.344, when you put it in your calculator, you'll basically get 1. So this is where you kind of have to make sure you have whole numbers. It's always going to be really, really close, so it's not going to be too tricky. So now these, step 3, these whole numbers are going to be my subscripts to the empirical formula, right? So my empirical is now going to be C1, which I'm not going to write the 1 because you never do that, H2O, okay? Because that subscript would also be 1. So my empirical formula is CH2O. All right, so now we're going to figure out the molecular formula using the empirical formula. And remember, to figure out molecular formula, okay, it's going to be the mass of the molecular formula, I'm just going to label it that, over the mass of the empirical formula, okay? So the mass of the molecular formula is given to us. It's 60, okay? So I'm going to plug in 60 grams per mole. And now I just have to figure out the molecular mass of the empirical formula, which by now we shall be experts in doing that, right? So the molecular mass for carbon, 12.1, 12.01. For hydrogen, it's 1 times 2 because I have 2. Oxygen, now we can say it's 16, okay? We don't need to be super extra with the decimals. So if you do 12 plus 2 plus 16, you'll get 30. Okay, so 30 grams per mole for the molecular weight of the empirical formula. So now I'm just going to plug that in over here. Okay. So if you do 60 divided by 30, you'll get 2, which like we said, we'll always get a whole number. So now I'm just going to multiply my empirical formula by that number to get my molecular formula. So I'm going to distribute the 2 to each element. So I'm going to have now C2H4O2. Right? And that's your molecular formula. And that is your final answer. Okay, so this was a 2-step problem. You'd have to use the percent compositions to figure out your empirical formula, and then use your empirical formula to get to your molecular formula. Just to review, using the percent composition to get your empirical formula, step 1, you divide the percent composition of each element by its own molar mass. You'll get 3 values or however many values. Then you look at those values and you determine which is the lowest. You divide all of the values by the lowest. Then you'll get your subscripts to your empirical formula, and then you determine your molecular formula from your empirical.